All right, we've talked about some of these terms before. We've talked about several of them actually. So now let's get into the actual geometry part where we're going to talk about points, lines, and planes. So these terms are all undefined. We know what they are, but it's kind of hard to define what they actually are. But so in general, a point's a location in space. It is infinitely small. It actually has no dimensions at all. Usually, we represent it with a dot, and then if I want to say name this place, I would name it with a capital letter. Always a capital letter. If you don't use a capital letter, you get marked wrong. And then, like another point could be point B. So these are two different locations in space because they're two different letters. Now, a line, if I give you 2 points, let's draw in 2 points. Give them any capital letters I want. It doesn't matter what letters we use. Let's use X and Y. Anytime I have 2 points, I'm allowed to connect them with a line. Now, this line goes on forever. Notice the arrowheads. This thing has length. Length is just one of my dimensions. My dimensions are length, width, and height. This is infinitely long. I would call this line XY. If I was to put a third point on this line, let's put a W. This is still line XY because you only name a line with 2 points. I could also call it line WY if it goes through both. Now, right here it says I could name it with a lowercase letter. A lot of times what you'll see is you'll do like, this is line L. So, but then you would have to spell it out. You would say line L like that. Okay, so those are lines. Always only 2 points to name a line, no matter how many points are on that line. Remember that, always 2 points. So if we put a Z, it's still line XY or WY. It doesn't matter how many points are on the line. Planes. Plane is any closed two-dimensional figures. 2 dimensions. Now it has length and width, no height. We usually call it a parallelogram. So like this would be a plane. So if the points, if we label it on our corners, let's just call it A, B, C, D. I can call this plane. And then any combination of the 3 points. I could say A, B, C, D, or at least 3. So the more you use, just kind of the better. We could also label it with a capital script letter and call it plane P. Cursive, that has to be a cursive letter. So collinear, is 3 or more points that are all on the same line. If any point is not on the line, then that group of points is non-collinear. So 3 or more, this would be a group of collinear points. If any of the points is not on that same line, they would be non-collinear. Collinear, all the points are on the same line. Non-collinear, at least one of the points is not on that line. Segment, we talked about this in the segment addition postulate. A segment is a piece of a line. It has a beginning, it has an end, and it has length. So it has 1 dimension. So if I give you a full line, but I'm only talking about that bit in the middle, I'm only talking about this much, that would be a segment. So this would be segment CD. Start at C, end at D. You can also say start at D, end at C. And then I don't care about anything outside of C or D. So a ray is a piece of a line that has 1 endpoint and is infinitely long in one direction. So let's give it an endpoint. Let's call this T. An array is going to go forever in another direction. So we would call this ray TR. This means start at T and go through R. That is not the same. These are not the same. This says start at R and go through T. So you can't say raise backwards. Raise always start at the first letter and go through the second letter. Another term to know is coplanar. Everything on this plane is coplanar. A, B, and C are all coplanar. They're on the plane. If I give you a plane and something is not on that plane, F is non-coplanar. Anything not on that plane is non-coplanar. Okay? So those are our quick definitions. So look at your bell work. Go ahead and knock this out. And then move on to the assignment. Alrighty, we'll see you soon, Patriots.